Hi, this is Mrs. LaBarbara. This is Physics Chapter 9, Current Electricity, Video 6. Today's topic is circuit symbols, and circuit connections. The objectives are know the definition of a circuit, know the definition of a short circuit, and its consequences and prevention. Know the standard circuit symbols for voltmeter, ammeter, fixed resistor, variable resistor, lamp, switch, battery, and a cell. To know the two types of circuits. To understand, a switch that's open does not allow current to flow. To understand, a voltmeter is a high resistance device that is placed outside the circuit. To understand, the ammeter is a low resistance device that is placed inside the circuit. Be able to select sketch diagrams of circuits using standard circuit symbols. Be able to determine the proper placement of voltmeters and ammeters. A circuit is a continuous loop through which current flows from an area of high voltage to an area of low voltage. The resistors in a circuit is load. So in this case, this animation, this slope indicates a battery. Battery does work on the charge. So now to push the charge up like you're lifting something up. So now the charge has energy, it can do work on the loads. So this is the loads, has 30 ohms. It could be your refrigerator. So charge does work, it will lose energy, then does do work on another load. This load could be your light bulb, right? Eventually it has no more energy, goes back, then battery does work on the charge again, so the cycle repeat itself again. A circuit without a load is called a short circuit. The circuit with a battery and a wire leading from positive to negative terminal without a load would lead to high rate of charge flow. Such a circuit is referred to as a short circuit. It would heat up the wire to a high temperature and drain the battery of its energy rather quickly. The consequence of a short circuit is electrical wire. For example, the diagram on the left side is an indication of a short circuit. In this case, no charge will go through your light bulb because the charge can see there are so many resistance in this side. So rather go this, the short circuit side, go back to the battery. But as a consequence, the current is very large in this part because it has very low resistance. And as a consequence of high current, the heat is produced. This can produce fire. So in order to prevent fire, we put a fuse in the circuit. The fuse is to protect to prevent fire. How does the fuse work? When the current is very high, the wire heats up and this fuse will break. So therefore, the circuit will not work. There will not be current, will stop the current. So sometimes we use fuse as circuit breaker. Circuit breaker is another way to protect the circuits from fire. These are the symbols we use in this chapter. So all the symbols are in your reference table. So voltage source, there are two types. One is cell, the other is battery. There are two types of resistors. One is regular resistor, the constant resistor. The other one is variable resistor. The other elements are a lamp. A lamp is really special resistor, but it has its own symbol. So if you are given a lamp in a circuit, you have to use a lamp symbol to draw in the circuits. The other element we use is a switch. The measuring devices are voltmeter to measure the voltage, potential difference. The other one is ammeter to measure the current. The two devices, voltmeter to measure the voltage, it has very high resistance and connected parallel. It has high resistance because you want to prevent the current going to your voltage, to your voltmeter, and connect to parallel to the resistor or any other loads you want to measure. Ammeter, on the other hand, measures current. It has a very low resistance. It can act as part of the wire. So this way it has a minimal effect on your circuit. So it connects in series to the elements you want to measure. Voltmeter and ammeter connections. So voltmeter connect to the parallel to the elements you want to measure. So another way to say is it is outside of circuit. It measures potential difference. It has very high resistance because when the current comes in here, you want to prevent the current to go to that side because you don't want the meters affect your original circuits. On the other hand, the ammeter has very low resistance. It's acting like a wire. It measures the current flow. It's placed inside the circuit. Example. The electric circuit diagram above, possible locations for ammeter and voltmeter are indicated by the circles 1, 2, 3, and 4. Where should an ammeter be located to correctly measure the total current? And where should a voltmeter be located to correctly measure the total voltage? Total current is current passing the battery, so you have to place the ammeter next to the battery. Same thing, to measure the voltage, for total voltage, you place the voltmeter next to the battery, outside parallel to the battery, and this one is inside next to the battery. So the answer is 1 and 4. Let's see, 2 is ammeter because it's inside your circuit. Series, connecting series to the elements you want to measure. It would only measure the current going through this resistor. Number 3 is outside your circuit or parallel to your elements. So this number 3 has to be a voltmeter, and it measures the voltage across this resistor. Switch is used to control current flow. When switch is open, there is no current. In this case, number 1, there is no current in R2. Number 2, there is no current in the whole circuit. Number 3, this case, there is no current in the whole circuit either because current cannot go through R1 and cannot go through R2. In the last diagram, current doesn't go through R1, but it does go through R2. Switch and short circuits. So 6 ohm lamp requires 0.25 amperes of current to operate. In which circuit below would a lamp operate correctly when switch S is closed? When switch S is closed, in this case, this part on the right is a short circuit. When switch S is closed, the circuit on the left is a short circuit. So neither A or B will work. C is when switch S is closed, the one on the left is a short circuit. So C is no good. D, when switch S is closed, circuit will work. There is no short circuit in this case. 2 types of connections, series and parallel. If this is schematic diagram, this is kind of physical diagram. You have the light bulbs. Series connection means there is just one way for the current to flow. This is the diagram for the light bulb. There's just one way. Now, parallel circuits, there is more than one way for the current to flow. So current come over here. As a matter of fact, in this case, there are 3 ways for the current to go. Then eventually they join over here and goes back. So here is schematic diagram of your circuit. Where do we find symbols? We find symbols from your reference table. Only use circuit symbols in your reference table to draw the circuits. Otherwise, you will be marked wrong. Parallel circuits, series circuits, there are only one way. There's only one way for the current to flow. So as more resistors or light bulb added, the overall current will decrease. As the more light bulb you add, light bulb has become dimmer and dimmer. This decrease in current is consistent with the conclusion that overall resistance has to increase. Right? If one of the 3 light bulbs in the series circuit is unscrewed from its socket, then the rest light bulb will immediately go out. This is kind of similar to the Christmas light. You know, the old types of Christmas light, when one light bulb goes out, the whole thing goes out. This is the series circuits. Parallel circuits, there are 2 or more loops. So the current comes from here. It will have 2 or more. It can go to the right or can go up. So as the number of resistors increases, this is interesting, the overall current actually increases. This increase in current is consistent with a decrease in overall resistance. Remember, the increase in current, that means resistance has decreased because your voltage is constant. Adding more resistors in a separate branch has unexpected results of decreasing the resistance. So this is very interesting. If an individual light bulb in a parallel branch is unscrewed from its socket, other bulbs are not affected. This is actually how our house is connected. One light bulb burns out, the other light bulb still goes on. Let's take a look at this example. So which circuit has the smallest equivalent resistance? So we know for parallel circuits, the more resistors you have, the less resistance you have. So the answer would be D. This is a parallel connection. Which circuit has the biggest equivalent resistance? That would be in series. The more you have, the more resistors you have, the more resistance you have. That would be, answer is A. Which circuit has smallest equivalent current? Smallest current would have the one has the biggest resistance. So the answer is A. Which one has the biggest current? The biggest current is the one has smallest resistance. So the answer is D. Which circuit has smallest equivalent voltage? They all have the same voltage because the battery looks the same. Okay. Check your understanding. So two electrical circuits are diagrammed below. For each circuit, indicate which two devices are connected in series and which two are connected in parallel. In series, in diagram A, series means they have the current goes the same way, right? It's ammeter and a resistor. They are next to each other. Ammeter and a resistor. Which one in parallel? When the current comes over here, it branches out. One goes to the light bulb, one goes to the speaker. So bulb and speaker are connected in parallel. How about in the second diagram? In the second diagram, speaker and ammeter have this, they are in the same loop. So that means the current comes into speaker, have the same current comes through ammeter. So they are connected in series. Which one connected in the parallel is the bulb and the resistor, because when the current come over here, some will go to the bulb and other will go to the resistor. They are branching out. So that's connected in parallel. That's it for today. Thanks for watching. See you next time.